One nation. One nation.
Folks, hi, and welcome to another edition of the Science of Philadelphia, where each week we take you on a journey with science and we make science exciting, entertaining, and fun. Folks, this week is no different. We're approaching the holidays. Once again, before we start, I want to put out happy holidays to everyone. Hope you enjoy your different holidays that come up, because now, of course, holidays are separated and folks from various backgrounds celebrate differently. But from me to you, Grand Hank, saying, hey, happy holidays. Let's roll into the Science of Philadelphia for this week. Now, this week, we're going to do something a little different here. If you look at my table is outlined with all kinds of machinery, all kinds of equipment and gadgets, things that I don't know anything about, but at the end of this show, I will know tons and tons of things about these things. Before we get started, though, let me give a shout out to some of the schools. I got to give a shout out to the Frankfurt folks last night. Grand Hank brought his entourage up there, and we did their after-school program with the science lab. Also, I want to give a shout out to all of the people that support the Science of Philadelphia. Now, this week, we're going to talk about lasers. We brought in a laser company, a company that specializes in doing events around the city. This company is called Pawn Laser. I'd like to introduce them to the show. This is Matt Falcone and Joe Reese. Welcome from Pawn Laser. Welcome to the Science of Philadelphia. What's going on?
How you doing?
Matt, what's going on, Joe? Now, these guys, your focus is the laser business. Now, before we get started, I need you guys to tell us a little bit of how you guys got started. Give me a little bit of information on your company.
Well, we started about 12 years ago, just basically tinkering around with different apparatuses here. We found some stuff in some old newspapers about building your own lasers. And that's basically where it started. We went from there, started constructing our own laser light show projectors, and eventually the lasers got bigger and more powerful, and to the point where you could actually go out and perform laser light shows for money.
So what do you guys do for a living? I mean, Pawn Laser, what's it all about?
Well, we have a production company, so we do anything from concerts. We do a lot of shows at the First Union Center and the Convention Center. That's just here in Philadelphia. We do this stuff all over the country and all over the world.
Beautiful. All right, now, before we move any further, each week, you know, we put out the side cue. This week, we're going to put the side cue out, folks. It's going to challenge you. It's going to make you go beyond what you know. Maybe you have to run to a dictionary for this particular question. Let's have that side cue. Let's get it up on the screen, and let's see what we mean. Now, here's the side cue for this week. What does the word laser stand for? Again, what does the word laser stand for? And the number to call is 215-875-3218. Again, the number to call is 875-3218. All right, so that is it. We want you to call in, see if you can answer the science factor. Now, as we talk a little bit about lasers, we're going to get into a discussion of what a laser is. So which one of you gentlemen, Matt or Joe, who's going to talk about what a laser is?
Well, we have some diagrams over here I'd like to show you just to decipher the difference between laser light and what it is, and the difference between that and regular light.
Okay, Joe,
over here.
Joe's going to go over, and Matt, while you're here, you might as well get ready to acknowledge this is Matt. So tell us a little bit about yourself, Matt, and how you got into the laser business.
Pretty much, I met Joe in '94. I've been working with Pawn for almost 9 years now, and pretty much I started off working for free, just coming to different shows, helping them out. We have a lot of friends that work like that now, and now I'm a part owner, and Joe, he's my best friend, and just me and Joe, and there's a bunch of us. There's about 10 of us all together in Pawn. We do these shows all over.
Okay,
but,
all right.
The thing I like about lasers is when you're doing a display with images, and with a laser, it can be as small as a television monitor, or it can be as large as the side of a mountain. Okay. And that's a cool thing about lasers.
All right, so lasers can vary in size. Yeah. So now we have Joe on board. Joe's fired up. He's going to talk a little bit about lasers. Joe, you take it away.
Okay, the best thing I can tell you, Hank, is the best way to understand laser light is to understand that light is waves. And I have a diagram here that shows you the way this wave is traveling right here. The way to determine what the wave is called, it's determined by wavelength. And that's the distance between these peaks right here. So you can have short waves and longer waves. Okay, there's three characteristics that have to do with laser light. And they are monochromaticity, and that's meaning that light, every single wavelength of light is different. Every color has its own wavelength.
Okay.
Ultraviolet has the shortest wavelength, and red light, as you see with this diagram here, has the longest wavelength.
Okay.
Now I have another diagram right here too. It shows a light bulb, the difference between a light bulb and a laser. Okay. As you see here with this light bulb, the waves of the light shine out in all directions. They consist of many different wavelengths because it's white light, which is all the visible waves together that make up white light. It's all the different colors in the whole spectrum, and that's why you see here there's different wavelengths, long ones, short ones, okay?
Okay, I can see that.
And now here you see the difference in a laser. A laser usually consists of a single wavelength and is made up of coherent light, which means that the beam isn't going to spread out. Like a flashlight, when you put it against the wall, the light's really big. If you stand across the room and back up, it gets further away you get, the bigger it gets, the circle. The laser, you back up, it's still going to be a dot on the wall, and it's very coherent. The beam stays very tight, and that's why you can shoot laser over a long distance.
Okay. That's so, and summing up what you said, the difference between monochromatic and a laser or regular light is that regular light is made up of a bunch of different wavelengths. And the laser light is focused, is coherent, everything is tight, and it travels together in a packet or a beam or however you want to describe it. So, Joe, what else do we have? We have anything else that we're going to show in terms of diagramming here?
I have another diagram here to show you real quick how laser is made. Okay, you have this here, which is the excitation mechanism. You have the active medium, you have the feedback mechanism, and the output coupler.
Now, the excitation, what is it called? An excitation?
An excitation mechanism. I know you're going, whoa.
Now that's a major term here. Now,
Right.
when you talk about an excitation mechanism, what are we talking about here?
I'm going to show you right now. Okay, you say excitation mechanism. You're like, what is that? An excitation mechanism is usually the power supply for the laser. It's a source that controls all the voltages and control settings for the laser unit. What's the active medium? If you want to go over here to this, I'm going to take this lid off. I don't know if you can see this right now, but I'm going to take this lid off.
All right, so let's get a shot of the laser here that Joe has just taken the lid off, and he's explaining.
Yeah, we don't do this too often.
That's right. So let's enjoy what he's doing. So what are you talking about here?
Okay, the active medium is contained within this glass tube right here. It's basically a really fancy light bulb. There's a gas inside of this glass tube right here, and this particular gas is the active medium. In this particular laser, we're using argon gas.
Okay, argon gas. Okay, argon. Now, argon is a gas that is a noble gas, and it's on a periodic table, folks. So if you check your periodic table, argon is in the far right-hand side of the periodic table. Okay, so go ahead.
Then we have the feedback mechanism, which is located in the very front and very rear of the laser. Okay, now, feedback mechanism is basically reflective. In the front, we have a partially reflective mirror. In the back, we have a 100% reflective mirror. It actually reflects the light that's being created inside the laser until it exits the form to partially reflect it out of the front in the form of a laser beam.
Now, do those mirrors focus the light? Is that what they do, or how does that work?
They don't really focus the light. The procedure that happens inside of this laser tube is called population inversion. And
well, you said another term that I can't let you escape with. So, do you know anything about population inversion? What is population inversion here?
I could explain that.
Okay.
Better,
Come on over here
and
let me stand over here, and you guys handle what you're going to do.
even better off, I have some diagrams over here where you can explain population inversion.
All right, so he's getting himself together to talk about population inversion, because I thought that was a major piece that should be explained. So Matt, you take it away. Let's talk about population inversion.
Okay, look, like Joe just explained, how there's two mirrors in the ends. One's 100% of reflective. You can see that right here. This is a fully reflective mirror. And on the front here is a partially reflective mirror. Now this is a diagram of a laser. I know it looks kind of weird, but this is what it would actually look like in reality. This here would be the 100% reflective end, and this part up here would be the partially reflective end. Now, inside here, these are atoms, these black dots. These consist of atoms in the ground state. And after you turn the power on your power supply, on the medium over there, what happens is the atoms get excited and they emit light waves. And what happens exactly is they bounce all over. And if you see here, they bounce up and back like that and all over. And eventually, they hit another atom and it gets excited. And this one emits light, and they bounce back and forth like this. And if you see in the diagram here, eventually they keep bouncing back and forth, and eventually it comes out the end of the front here of the partially reflective mirror in the form of a laser light beam.
Okay, so it comes out as a focus beam.
Yes.
So all the excitation goes on inside that tube.
Yes.
And then when they bang it back and forth, and then eventually they line up, they come out of the tube as a beam.
Yes.
All right, good. All right, so what do we have next here, Joe? What are we going to talk about next? We have a load of stuff here. I'm always excited when I see equipment. Tell me what we have.
Well, we have a bunch of stuff out here. As you may or may not know, there's a lot of different types of lasers, okay? The reason why we use, there's different reasons why you would use a particular gas. In this case, in this laser that we talked about earlier, we use argon gas.
Now, what are some of the gases that you can use in a laser? I know argon is one.
Yeah, there's another one. I was going to show you this example right here. This is a helium neon laser tube right here. These are all helium neon, meaning that they're using helium gas and neon gas together in order to create. Now, this helium neon laser will actually produce a red beam.
Okay.
Okay. Now, this laser here, the argon laser, will actually produce green and blue because it's actually creating two different specific wavelengths of light.
All right. So let's slow up right quick. The helium laser. Now these are noble gases.
Right.
So they're in the noble gas column of the periodic table.
That's
argon,
right.
helium, neon. Now the helium laser produces a red. What color is it? Is the beam red?
Yeah, the beam's actually red.
Okay, and the laser here, which is an argon laser, produces green and blue. Is that correct?
That's correct.
So if I'm at a concert or if I'm somewhere and I see a laser, a blue laser or a green laser, then I know it's coming out of an argon laser. In some cases, or?
In some cases,
All
yes.
right.
If you see blue and green together, most commonly they're using an argon laser. But,
Okay.
Today, typically, this one thing we didn't discuss earlier, this laser right here, you need to hook up water lines to it. As you see coming out of the back. Sorry.
This holds
is
them up
actually
and,
hooked
and
up
show
over here.
people so they can see. They can get a feel
I don't know if you can see this, but this is actually the water cooling lines for this laser system. In order to run this laser at all, you need to have water flowing over it at 3 gallons per minute to actually cool the temperature.
Because it heats up?
Yeah, it gets really hot. It's a plasma tube in here, and it gets extremely hot. What will happen if the water stops going through it, the glass will break down and melt, and the tube will be destroyed. So a lot of times what you'll see today is a new technology that came out where they use YAG lasers.
Okay.
And diode pump solid state lasers, which don't require water, but most commonly they're only single frequency, so you're only going to get one color, which is green.
Okay. All right. But Joe, proceed. What else do we have here?
Okay, we have here just different parts of the inside of a laser tube, what's coming down the center here. And this is a ballast tank. This holds the gas for this laser tube. Then this would normally have glass around it, but it's been broken away, and it's just leaving you the center rod and the ballast tank here.
Now, do you have to refill the laser with gas, or does that gas stay in there for the duration of the laser?
It does get used up
Okay.
It does get used up.
And they
you
have
can
mechanisms where you can refill it or send it
You
away
can
to get
refill it. It's not just as easy as just pumping gas into it, because you need to do this stuff in a very clean environment
and under pressure.
impurifications and stuff. So a lot of times what you need to do is you actually need to bake the lasers and burn out all the impurities before you can actually introduce the gas back into the system, which has to be done in a scientific laboratory.
Okay.
In a clean room environment.
Now, just before we jump into something else, how did you get into this whole laser business? How did you guys meet up, and how did you get into this? Because this seems exciting to me to be able to put on laser shows and do things like that. So how'd you do it?
I was always into art and stuff like that, and painting, and I was always into music and stuff as well. I produce music, and I have a music studio. And
now you guys have a record label, right?
Yeah.
It's Pawn Records.
PawnRecords.com.
Okay, so they produce records. They are in the laser business. Now, Matt, how'd you get involved? Come on over, Matt. We got plenty of room over here. How'd you get involved in the laser business?
I mean, pretty much, like I said before, I met Joe around '94, and he was doing a lot of shows at these concerts. And I would always see Joe at the concerts and come down and help out. And I was always interested in the lasers because, I mean, you know, if you ever see a laser show in a big arena or outdoors, it's amazing.
I was down at the First Union with you guys doing a laser show, and you know, we really had a good time. You guys have footage? Is that what you guys have? You have some footage of that you can show, or was that just a mirror on the screen or something? No?
That actually looked like part of our website.
Oh, okay, it looks like a website. Okay, so they can go to your website?
Yeah, the website,
And,
yep.
Well, give your website out.
That's www.pawnlasers.com, and that's laser spelled with an S.
Okay, pawnlasers.com is the website. So, Joe, finish telling me about some of the equipment we have here that operates lasers.
We have some really neat stuff. I don't know if we're going to be able to go into too much detail about everything that we have here today, but I'm just going to look at the table and start pointing a couple things out.
Okay.
This laser right here. This is a lot different. This is laser you can't use this for laser light shows. This laser right here is used for cutting.
Okay.
Okay, it cuts metal. It's a CO2 laser.
Now let me ask you another question. What are lasers used for? What are some of the things that lasers are used for?
You see lasers in supermarket scanners. They do lasers for scientific testing.
Eye surgery.
Eye surgery. What else? Let's run down
Hair
the list,
removal.
man. These guys know it all. I don't. I'm a scientist, but I'm learning.
Research and development.
Okay.
Measurement.
Measurement. Okay. A lot of construction people use those things in putting tile down and lining up sheetrock. See, I know a little
Defense systems.
Defense systems for laser-guided missiles and things like that we see on TV. What are a few other things?
Of course, laser light shows, displays, laser billboards.
Now, I noticed you had something here that was, what is this?
This is a hologram.
All right, you explain what that is. I just see it there. It looks glowing, and let's talk about that.
You can probably get a better look at it over here on the overhead
there
projector.
you go. Sure.
Oh, look at that.
It looks like a 3D image here on it, but it's actually a flat surface. When you move it around, you can see it.
Okay, and what that's using a laser technology?
Yeah, it's created by using a laser. There's a huge process involved with creating a hologram. You can find more information about holograms on the web by doing a search for it, but you use lasers in order to create a hologram.
All right, well, tell me some more, Joe. You got loads of equipment here.
Okay, right here we have a very interesting device. This is a special crystal. It's called a PCAOM crystal.
Well, can it come out?
You can take it out, sure.
All right.
It's got seals on it, so.
And what is this used for?
This is an electromechanic optical device. It's almost like, if you know what a prism is, okay?
I know what a prism is.
This is almost just like a prism on the inside, a very tiny prism, which is hooked up through electromagnetic optical chain, and it takes frequencies sent from the computer, which actually moves the little optic, the prism inside, back and forth in order to change colors using a computer for a laser. I spoke earlier about how you can have a red laser, and you can have a green laser, and you can have a blue laser color. You can also have a laser that contains all three within one unit. Wow. Once you do that, you have a white light laser. When the beam comes out in the color white, what you do with the white light laser is you pass it through this crystal here, which hooks up to your computer, and that's how you can get a lot of different colors out from the laser
So
during
you
the
do,
performance.
can you, with a white laser, can you do like a rainbow of colors?
You can
or
do
is
a
it
rainbow of colors.
just- Okay.
With this
All right.
crystal, you can actually do 16 trillion colors.
16 trillion, not
16
million,
trillion.
not billion.
This is the
but
driver
trillion.
for it right here.
Okay.
I don't know if you want to take a look at it, but
All right, and what is this?
this is the driver for this crystal right here.
Is this a computer inside, or is it just?
It's not really a computer. It's kind of
a signal, something.
yeah, it's a kind of like an amplifier card type of thing.
Okay.
It's very scientific. It was originally created for the military. Okay,
It translates the signal from the computer into
Okay.
Yeah, it
an
takes
acoustic
the-
signal. The crystal operates like the piezo effect, and PCAOM, it stands for polyacoustic optical modulator.
Okay.
So
All
it
right.
means a multicolor modulator.
So now, what else do we have here? I see
Okay.
computers. I see.
Now we talked a
all
lot
kinds
about
of
is
stuff.
the science about lasers and you know, the different types of things that go into making up a laser. What we have over here are computers. I don't know if you can zoom up on them now. We're going to start talking about what we do, which is the light shows. Okay, you know, we use different computer systems like laptops and other
I would
type
figure
of
you
computer
would have
systems.
a big computer, man. But I see you have a regular.
Actually,
a laptop.
yeah, you can do.
Are these special, or can I just take my Macintosh and plug it up, or my PC, or do we need to, you know, re-rig it in some kind
You're
of
gonna
way?
have to rig that Mac.
Okay. All right.
We usually use PCs for laser light shows. You'll see these PCs, the laptops look pretty big because they're actually they're docked into these docking stations.
Okay. Now,
You need a special card, and that's why we need the docking stations. The card actually, the software and the card go hand in hand. You need the card in order to create the signals, to drive the images and the different controls for your laser light show, and that's all contained within the
laptop.
controlled by the laptop and contained inside the docking station.
Okay. Now, can we get some sample work, man, of what you guys do? Can you program something in, or get me a show or something, man? These guys do laser shows. I'm you know, hoping that my
Let's see if I
audience
can make
out
it
there
around here with this cord.
can get a laser show. So we wanna set up so that we can show some of the work that these guys do, because they do this on a major scale. Again, I was down at the First Union Spectrum with these guys on numerous occasions. They actually did a laser show for me as well when I had my premiere party for the Science Lab, which is coming up, folks, too. So you want to look out for the Science Lab at Grand Hank, which is going to be premiering February 4th, 2003, all right, at 2 p.m. on Tuesdays. All right, so Joe, what do we have here? Let's roll.
I'm going to show you a little bit what we do. If you can zoom in on this computer screen right here. This is one of the software programs we use. Contained in these little boxes right here are the different images and graphics that we can project from the laser system. What I'm going to do real quick is show you guys how we put words and stuff up on the wall. So I'm going to click this text box over here. I'm going to type in the science of Philadelphia.
And what he's typing in is going to be projected where? On a screen? Or do we
That's
have a
correct.
screen that we can fire a laser up and see the results of that? I'm looking for a laser show, folks. And this also goes real good with music. So with hip-hop music, especially with rock and roll music, with alternative music, this thing really goes well. Laser shows really go well. And you can see the names flip and do all those things. So Joe's here trying to fire it up and to get things together so we can do a laser show. But in the meantime, while we're waiting for Joe to get his laser thing together here, Matt, I need you to come on board and talk a little bit about the safety of laser and the danger of dealing with a laser device.
Oh, I'm actually going to come back over here to the
All right,
overhead
go ahead.
projector again.
He's going back over there to talk about it. So let's talk about the danger and the safety of lasers and why they say you don't look into a laser. Matt, you got the floor.
Well, lasers are very dangerous devices. They're regulated by the FDA, the Food and Drug Administration. And they have a certain department. It's a CDRH. Stands for the Center of Devices of Radiation and Health. Now, there's 4 hazards that can happen from a laser. The first hazard would, of course, be a fire. I mean, you could have your laser on in your laboratory, and you walk out the room, the phone rings, next thing you know, the beam that was hitting the curtain on the wall catches on fire. It happens quite often. The lasers that we use for laser light shows, they can light a cigarette in less than a second. So, I mean, that shows you right there, I mean, how powerful they are. So, of course, the second hazard would be a burn. I mean, you're working with your equipment, your hands, next thing you know, like, in less than a second, your hand could be burned. I mean, this happens to us all the time while we're aligning our equipment up in the show. The third hazard that could happen would be an electrical hazard. Lasers are high voltage, like you shown before. This laser that we showed you before on the table here, it requires three-phase electricity, and it's 208 volts, and it's about 50 amps, and that's some very high power.
That's powerful.
Yeah, I mean,
that's very powerful.
You touch the wrong components on the machine, and you'll get blown like 10 feet feet back.
Do you guys work with special gloves or anything, or
we use tools that are they're rubber coated. We're just trying to have her hand behind her back, but when we go to a venue, if the building has like a house electrician, we always try and get them to do the work for us, like tying our electrical power. And of course, the fourth and the most important hazard would be an eye injury. You should never point a laser at a person and never look into the beam of a laser. Now, if you want to take a look down here on the overhead projector, this here is a picture of an eyeball. Actually, your eye is like an optical lens. It's like an optic. So when a laser beam hits you, enters the eye, it gets focused down because it enters the optics of the outside of your eye, and it focuses down into like a pinpoint. As you can see here, it enters the eye completely. It'll damage the front surface, and it'll come into the rear end, the back end of the eye, the macular lutea it's called, and it damages that area. Now, if you want to take a look over here on the screen, we have that text came up.
Okay, so this is an example of Joe doing a laser show, putting the laser up.
Putting text and words on the wall.
Putting text and words, okay. And can you rotate the words and do things like that? I know you guys can do it all.
You can do it all.
You can do it all.
Flip it, you can flip it, roll it, 3D.
Wow, that's really nice.
We have another example of a show right here, too.
Oh, yeah.
Where we'll show you a little bit of some graphics and things of that nature. A lot of times when we do shows, we'll be using a couple different computers back and forth, so we can switch back, so we can see here science and keep going back and forth to the show.
Okay. All right. So as we wind down, let's let our laser show keep rolling. Now, so you guys are Pawn Laser. For those who don't know, they can visit the website at www.pawnlasers.com. Is that correct?
That's correct.
And you guys do laser shows for big concerts, for small venues. This is how you can get in contact with the people from Pawn Laser, Pawn Entertainment Group at P.O. Box 45570, Philadelphia, PA 191 something. So now we're wrapping it up. So, and leaving it in closing, remember, I'd like to leave you with knowledge is power. Anybody can be a scientist, including you. Matt and Joe, thanks for coming and hanging out with the Science of Philadelphia. And enjoy the laser show. As Matt and Joe, we sign off with the Science of Philadelphia. We'll see you next week.